All right, so the last question I asked was, if we just consider the same energy level transition, here it just switched one from 1 to 2. That's one jump. Here's 2 to 3, one jump. Here's 3 to 4, one jump. Why is there a difference in energy? You could also consider if you did 2 jumps. Here's 1 to 3 versus 2 to 4 versus 3 to 5. Why are these different numbers? Okay, Jackie, you wanted to offer us what you wrote down. What did you say?
I said that like the first part.
This one right here?
Yes, it's closer to the nucleus.
Ah, it's closer to the nucleus. And I asked you guys, and about half of you raised your hand and said that your sentence included something about the nucleus, right? Distance from the nucleus. Okay, so here's my next question. All right, just ignore that for a second. Here's my next question. What is special about the nucleus? Why do we think the nucleus is having an effect?
Because it's a force.
Ah, very good. Other classes, they were trying to get all fancy. They were trying to talk about strong forces and I don't know, other things. But really, it's very fundamental. It's because the nucleus has protons and neutrons in it. So it is very, very positive. And what's an electron? Negative. Okay? So if you've got this negative electron very close to the positive nucleus, isn't it held on very, very tight? There's nothing shielding it. So it's held on very, very tight. So it takes a lot of energy to go further away. Here, this one that's already at the second, or certainly this one that's already at the third, it's already a little bit far from the nucleus, so easier to go farther away. And I want you to consider this. One analogy that might be really good is blasting a rocket into space. Doesn't it take a humongous explosion, a huge amount of fuel to get a rocket to lift off? It takes a huge explosion, okay? And so that gets the rocket to go off. But then once the rocket is way up high, I mean, even like you think about a mile or 2 high, isn't it much easier for it to keep going? Do we have to keep having that huge explosion? No, we don't have to input as much. So it's the same kind of analogy, but it's just Coulombic or electrostatic or plus a negative attraction. That's it, okay? So what I have seen more on the AP exam is not so much them having you calculate an energy, but them saying which of the following will emit the most energy. 2 to 1, 4 to 3, 6 to 5. No calculations involved. What would you say? 2 to 1, the closer in. Okay? So that's really the conceptual thing that you need to take away with this. And if you ever have to explain it, it's a simple matter of attraction to that very, very positive nucleus. That make sense? Okay, good.